right? In first part, we have mean value theorems, Rolle's theorem. Three mean value theorems are there. Rolle's theorem, Lagrange's, and Cauchy's theorem. These are all there without proofs. And first two theorems, we have geometrical interpretation also. That means just we want to know how the students have understood the theorem. And for that purpose, the first two, we are taking the geometrical interpretation, geometrically how you people have understood. And going to the second part, we have partial derivatives, Jacobian transformation, maxima and minima, and functions of several variables. That is, and maxima and minimum we have for 2 variables and 3 variables. Both are there. Okay, a method of Lagrange's multipliers. I hope you are all there with your books. I want you people to copy it simultaneously. Please take out your books and copy it simultaneously. The topic in the third unit, the theorems are Rolle's theorem, Lagrange's theorem, and Cauchy's theorem are there. 3 theorems are there. Please put it in the chat box whether you are copying it or not. The topics in module 3. Yes? Have you copied? Yes, done. Okay. So because here I can't hear your voice, please continuously you put it in the chat box. Otherwise, I feel that I am alone there in the class. Right. So to understand this 3 theorems, that is Rolle's, Lagrange's, and Cauchy's theorem, we need to understand the main thing, that is what do you mean by a curve, when it is said to be continuous, and when it is said to be differentiable. So for that, I'll go for the whiteboard. Okay. Slowly, I'm going to the first module, first part of third module. Module 3. Module 3, we have Lagrange's theorem. I mean, Rolle's theorem, first one. First one is Rolle's theorem. Secondly, we have Lagrange's theorem. Lagrange's theorem. And third, we have Cauchy's mean value theorem. Cauchy's mean value theorem. Cauchy's mean value theorem. Okay, ma. Understand it carefully, children. These 3 theorems are applicable on continuous curves, continuous and differentiable curves only. For when the curves are continuous and differentiable, then you can say that they hold some solution in some interval. Okay, continuous and differentiable. What do you mean by holding some a solution? Because the concept is, before going to these theorems, we need to understand literally what the continuity and the differentiability of the functions. Okay, suppose if I have x square minus 5x plus 6 is a polynomial equation equal to 0, you all know that x is equal to 3 comma 2 is the are the values for the function. That means that they are the roots for the function. That means this curve, that is f of x, which is equal to x square minus 5x plus 6, meets the x-axis at x is equal to 3 and x is equal to 2. X is equal to 2 and X is equal to 3. That is the meaning of the roots of the equation. So this in meeting the point is said to be the solution of the polynomial equation. The point where it meets the x-axis is called as a solution of the equation. And this, in order to find out the solution of a curves, first we need to see whether the given curve is continuous or not. Okay, continuous. That means, what do you mean by continuity? A simple English meaning is that when you draw a curve, we should not lift our pen between the intervals where we are searching. Suppose if you are searching between 2 and 3, between 2 and 3, the curve should be a continuous curve. There should not be splits in the curve. If there is a split in the curve, it means that the curve has broken there and it is not continuous there. And suppose if I refer this curve, you can see that the here and here the curve has broken here, and that what happens, we'll have the minimum and the maximum value at the same position, and you can't tell about the increasing and decreasing of the function, and you can't tell about the solution of the function. So all these are interlinked with the concept of the continuity. So whenever you refer about the theorems of mean value theorems, these are all the 3 mean value theorems. First thing, we have to see whether the function has eligibility of these theorems or not. What do you mean by eligibility? That means it should possess some it should satisfy some condition in order to apply these theorems. So that satisfaction, or 2 conditions are there. That is, first, that the curve should be continuous, and second, that the curve should be differentiable. So continuous means, geometrically, if you understand about the continuity, it says that whatever curve you are taking, it should not be broken in between the interval where you are searching, right? Suppose if I have x cube minus 5x square plus 7 is some curve I am referring. Taking from -2 to 2, between -2 to 2. So in between these 2 points, the curve should not be broken. Suppose if I take some point like 1 by x, some function like 1 by x, what happens? So here, suppose if I take the interval -1 to 1, you all know that at x is equal to 1, this function is nothing but that is discontinuous function, because it goes to infinity. So when you plot a curve, so you can't plot the point like 0 to infinity on the graph. So what happens at that point, the curve shows the discontinuity. So that is a geometrical understanding of the continuity of the curve. And look, children, whenever you speak about this continuity, it is taken in the open interval. Open interval, what is it? Because the intervals means a specified meaning in mean value theorems. These are called as a closed intervals. And these type of curves, brackets, are called as a open curve, open intervals. So what is your difference between the closed and the open interval? Suppose if I have said a comma b is a closed interval, that means strictly I'm stopping at a and b. Suppose the same value a and b are the open interval, that means at the side, at the neighborhood of a and b, that means below a and after b, we have infinite number of points. Just like, suppose if I have open interval 0 to 1, it means that so many infinite number of points will be there around O. That is 0, that is 0.1, 0.12, 0.13, so on. So there is no end here. So the brackets are all open here. And strictly, if you say that it's closed, that means at 0, the interval has been cutted. So when you speak about the continuity, we'll speak in the open intervals rather than the closed interval. The simple meaning of the continuity is the curve should be continuous. That means when you draw it on the graph, the pen should not be lifted. Each and every point, each and every domain, the range should exist. then you can say that that particular curve is continuous in that interval. Is that is clear, all of you, right? So that is the first meaning of continuity. And going to the differentiability of the curve. Let me erase this. Whenever these curves are continuous and differentiable, then you can say that they are applicable and for applying they are eligible, they satisfies the condition of the mean value theorems, and you can apply Rolle's, Lagrange's, or Cauchy's theorem. So the next one is we have, okay. So the next one is differentiability. Differentiability. What do you mean by differentiability? Okay, let me take this example. Let us suppose that f of x is equal to some function we'll take where it is not differentiable. Okay, suppose root x. Okay, for all x belongs to some interval, will take open interval, or let us take from -1 to 1. Yes, -1 to 1. Let us take from -1 to 1. I am taking an example of f of x is equal to root x for all x belongs to -1 to 1. And just I want to understand the meaning of the word continuity and differentiability for the function. I have taken an example here. Right now, continuous. See, for all the values between -1 to 1, -1 to 1 are all real numbers. We don't have any complex numbers here, isn't it? Okay, as I'm taking open interval, I'll remove this -1, right? Because -1 is not acceptable, because if you substitute -1, we are going to get a complex number. So this function is not applicable on the real numbers. So for this, we'll better take the starting point as 0, so that we may not get confused. Suppose 0, 1. I want to refer the function, the continuity of the function in the interval 0, 1. So between 0, 1, whatever point you substitute, suppose if x is equal to 0, then f of x will be equal to 0. So if x is equal to 0, f of x will be equal to 0. F of 0 is equal to 0, right? If x is equal to 0.5, then f of 0.5 is equal to under root of 0.5, and which is nothing but some value, we'll get it 0 point some value, right? Okay, which can be plotted on the graph. So on and so forth. Whatever values you take from 0 to 1, you could able to get the domain and the range here. Okay, so domain is 0.5, and suppose that the under root of 0.5 is some 0.25 some value. So here you can say that these points are domain and the range, so on up till 1, 1. So all these points are finite points, and they can be plotted on the curve. So we will get a continuous curve. So we don't have any doubt that this function is not continuous. Okay, so this function is always continuous. Now going to the second point, differentiability. Let us check about the differentiability of the function in this interval. Differentiability ante we have to do the derivative part. That means, what is f dash of x? F dash of x is equal to -1 by 2 root of x. F dash of x is equal to -1 by 2 root of x. Okay, you all know that when x is equal to 0, if x is equal to 0, what happens? X is equal to 0. This becomes f dash of x will become 1 by 0, which is nothing but infinity. So here the derivative does not exist at x is equal to 0. Even though the function is continuous, the derivative is not existed at that point. So this function is not applicable in this interval. In this interval, it is not applicable of one of the mean value theorems. Is it clear, right? Okay. Is it clear? Suppose if I change my interval from 0 to 1 to, I'll change my interval from 1, 2. Okay. See, between 1, 2, between 1 comma 2, whatever point you substitute in the function, you are going to get a finite value, isn't it? Root of 1 is a finite value, root of 1.1 is a finite value, so on and so forth. Root of 1.99 is a finite value, and between two integers we have infinite number of rational numbers. So for all those points we are going to get a finite value. That means that for each and every point that you are substituting, we'll get a fixed point so that we can plot it on the graph. So that means that the root 2x becomes continuous function in this interval. So from this, the idea that you have got now, the continuity of the function will be based on the interval that we are taking. మనం ఏదైతే interval we are taking, based on that interval the continuity can be discussed. So without the interval we can't discuss the continuity nature of the curves, okay, because some curves between some points are continuous and between another points they may be discontinuous. So like that it always happens. So whenever you discuss about these theorems, no, definitely he will give the interval. So without the interval we can't say neither the continuity or the differentiability of the curve, right? Okay, similarly in 1 comma 2, the derivative is minus 1 by 2 root x. So if x is equal to 1 or 2, the value, the f dash of 1 exists, and f dash of 2 also exists. So therefore this curve in this interval is always differentiable, but in the 0.1 it is not differentiable. In this 0.1 it is not differentiable, just I've showed now, right? So what happens, what the conclusion is that whenever you want to check the differentiability of the function, you have to differentiate that. And in the differentiated function, you try to substitute, you try to imagine one point where it goes to infinity. Supposing if you can't get any infinite point, that means that that function is continuous in the given interval. Otherwise, it goes to a discontinuous function, or not. I'm sorry, not differentiable function. Is this concept is clear for you all? Suppose I'll take one more example. Instead of root x, I'll take one more example to discuss the continuity and discontinuity of the function, because of course we have fixed questions in this unit, but still when the question changes, you should be in the position to justify yourself correctly whether the function is continuous or discontinuous. So blindly we can't say all the functions are continuous. Blindly we can't apply all mean value theorems for it. Okay, so suppose if I have mod x for all the interval, for all interval, suppose if I take minus 1 to 1, it is continuous, because for all the values from minus 1 to 1, mod x gives finite values, so it is all differentiable. Is it clear, right? So but if you go for the it is continuous, it is always continuous. Is always continuous. Why it's continuous? Because but between each and every point from minus 1 to 1, the function f of x is equal to mod x is always continuous and gives a fixed values that we can plot it on the graph. The points can be capable of putting it on the graph. So it is always continuous. So going to the differentiability. What about differentiability of the function? Differentiability of such type of functions, mod functions, have to be checked for LHD and RHD. That means left hand derivative should be equal to right hand derivative. So whenever you get mod functions, in order to check the differentiability, we have to check whether the left hand derivative is equal to right hand derivative. What do you mean by left hand derivative? Left hand derivative, suppose if I want to check it around x is equal to 1. I want the differentiability of the function of around x is equal to 1. Just we have to check whether the limit x tends to 1 minus f of x is equal to limit x tends to 1 plus f of x or not. So these two things we need to check it now. Here you see 1 minus. You all know that the mod function takes two different types of values. Minus x if x lies in the domain less than 1, right? And plus x if x is taken greater than 1. Of course, it becomes 0 when x is equal to 0. So if it is x, so two types of values it accepts. So here what happens? The limit of x tends to 1 minus f of x becomes minus x, and here limit x tends to 1 plus, that means after plus the mod function will acts like plus 1. So 1 plus it acts like x. That's also when you substitute x is equal to 1 here, 1 minus it doesn't mean that minus 1 1 minus means that the value is below minus 1. So atla ardham vastadi. Is it clear, right? 1 paina minus pettina I mean sorry, a minus e minus a ki chaala teda untadi. A minus ante we are referring to the numbers which below minus a, and minus a ante we are referring the I mean minus of a, like this. So that there is a lot of difference here. So ikkada manaki emoutunte x is equal to 1 substitute cheste minus 1 vastundi, and ikkada 1 substitute cheste 1 vastundi. So 1 is minus 1 is not equal to 1. Therefore this function is not differentiable. Mod functions are not differentiable functions. Eppudu kuda mod functions ki manamu differentiability avvavu. Eppudu avvavu ante manam teeskunna ee interval ni batti. Interval manam em teeskuntunnam ikkada chudannama 0 nunchi same minus 1 plus 1. ఎప్పుడైతే మన ఇంటర్వల్ మైనస్ a to a ఇలా తీసుకుంటామో మోడ్ ఫంక్షన్స్ కి ఎప్పుడు డిఫరెన్షియబిలిటీ ఇవ్వదు. అలా కాకుండా సపోజ్ ఇఫ్ యూ టేక్ ఫ్రమ్ a to b both are positive or both are negative, అప్పుడు అది డిఫరెన్షియబిలిటీ ఇస్తుంది. సో I want to say that the differentiability and the continuity are completely depends upon the interval that we are taking. Man తీసుకుంటున్న interval ni batti a differentiability and continuity will be dependent, but not blindly. As you like, we can't say without the interval we can't say whether it is continuous or differentiable. So ivi rendu manaki chaala main parts ga, I mean main characters laga untayamma whenever you want to apply these three theorems. So till now I didn't go for the theorems inka open cheyaledu. Just I have discussed about the continuity and the differentiability of the function. Tell me if you have any doubts in this. Please tell me if you have any doubts in this. Please put it in chat box. Manam doubts unte chat box lo pettandi. Are vintunnara ra nenu okadani cheppuntunnana? Are you all listening? Okay. వింటున్నాం మ్యామ్. వింటున్నారో అక్కడ తినుకుంటా వింటున్నారు ఏమోరా. This is too bad. All the 3 units are very tough. Hope so that we'll have offline classes soon, because the coming 3 units are very difficult. They are not just like matrices. Already I've alerted you people, but our bad luck that when I started my typical topic, we have online classes. I felt very bad yesterday. Okay, so February lo manaku offline classes untayani aashiddam. Got my point? Right. Okay, please take down the continuity of the function. Continuity of the function. Situation demands. Right. Right. Amma, somebody have asked some interval. Continuity also depends on interval. Yes, continuity and differentiability and adi manaki interval ni batte untayi amma. Okay, interval ni batte untayi. Is it clear? Endukante suppose nenu I'll take an example like x to the power of 3/2 annanu ankura. If I take some example, a function just like this, idi continuous ah kaada ante em cheptavu daniki? Em cheppalem. Is it clear? Ade suppose I want to check the continuity ante a curve continuous ah kada ani naku interval lo check cheyalanunnaanu anko appudu nu cheppagalugutu adi nijanga ee interval lo 1, 2 madhyalo ఆ కర్వ్ ఎప్పటికీ కంటిన్యూస్ ఉంటుంది. ఎందుకంటే నువ్వు ఏ వాల్యూ తీసుకున్నా ఎక్స్ ప్లేస్ లో ఇన్ బిట్వీన్ దిస్ 1 and 2 నాకు ఇన్ఫినిట్ వాల్యూస్ కానీ ఇండిటర్మినెంట్ వాల్యూస్ కానీ ఇవ్వదు. సో సపోజ్ ఇఫ్ ఇట్ ఈస్ గివింగ్ ఎనీ ఇన్ఫినిట్ ఆర్ ఇండిటర్మినెంట్ వాల్యూస్ యూ కాంట్ సి దిస్ ఇస్ ద రేంజ్ డొమైన్ దట్ యు ఆర్ టేకింగ్. 1 అని తీసుకుంటున్నాం. ద ఆన్సర్ ఈస్ ఇఫ్ యూ సబ్స్టిట్యూట్ 1 some value will get it, right? That is the domain value. So two coordinate pairs x comma y untai. So if x and y both are finite, then you can flexibly put it on the graph. Suppose if x is finite and y is infinite, what happens? You can't put the point on the graph, isn't it? Suppose I want you to ask where does this point lies, 1 to 2 to infinity, where you are going to put that point? పెట్టలేం కదా. సో అట్లా ఏమవుతుందంటే అది డిస్కంటిన్యూస్ అవుతుంది. అర్థమైందా? ఇప్పుడు నాకు పాయింట్ ఇది వచ్చిందనుకోరా 2, అని వచ్చిందనుకో ఏదైనా ఒక పాయింట్ 2, of course you can plot it x value 2, but y value infinity అన్నప్పుడు నువ్వు ఎక్కడ పెడతావు ఆ పాయింట్ వెళ్ళినప్పుడు కర్వ్ అక్కడ వరకు వచ్చి ఏమవుతుందంటే డిస్కంటిన్యూస్ అయిపోయి మళ్ళీ వెళ్ళిపోతుంది. అది ఈ పాయింట్ దగ్గర మనకి ఎంత 2, ఉంది కాబట్టి ఇట్ ఈస్ డిస్కంటిన్యూస్, ఇట్ బ్రేక్స్ ద కర్వ్ ఈస్ డైరెక్ట్లీ బ్రోకెన్ అని చెప్పొచ్చు అనమాట. Got it? Okay. So does the continuity also depends on the interval? It always depends upon the interval, not situation. It always depends upon the interval. Any doubts? Any doubts, ma? And tell me one thing, Nana. When the tan theta, suppose if I have tan theta, right? Tell me this function f of theta, where at what point of theta the function is discontinuous. Tan theta ni icchanra. So ఇది డిస్కంటిన్యూస్ కర్వ్ అందరికీ తెలిసిన విషయం. దట్స్ గుడ్. 90 degrees దగ్గర, ఎందుకంటే మనకి tan 90 degrees దగ్గర ఏమొస్తుంది, tan 90 degrees దగ్గర ఇట్ గోస్ టు ఇన్ఫినిటీ అయిపోతుంది. ఇస్ ఇట్ క్లియర్? ఇన్ఫినిటీ అయిపోతుంది. సో యూ కాంట్ పుట్ ఇట్ ఆన్ ద గ్రాఫ్ లో. మనకి 90 degrees దగ్గరకు వచ్చి అది ఆగిపోతుంది అది కర్వ్. అందుకే ఎక్కువ చూడండి మనకి మోస్ట్ ఆఫ్ ద tan కర్వ్స్ విల్ బి ఇన్ దిస్ మోడల్. ఇలా డిస్కంటిన్యూస్ కర్వ్స్ వస్తూ ఉంటాయి. అదే మీకు సైన్ కర్వ్స్ అనుకోండి, దెల్ బి లైక్ దిస్, ఇజంట్ ఇట్? ఇట్లా ఉంటాయి. సైన్ కానీ కాస్ కానీ ఇట్లా కంటిన్యూస్ కర్వ్స్ వస్తాయి మనకి. గాట్ ఇట్? ఇప్పుడు దిస్ మీన్ వాల్యూ థియరమ్స్ యు నో దే ఆర్ ఆల్వేస్ టెల్స్ వేర్ at what interval, from what interval to what interval the functions are continuous, and at what point that touches the x-axis. Does it touches the x-axis? Some curves, no, before touching the x-axis they'll go like this. So the point where it touches the x-axis, that we are taking as a solution. If it doesn't touch us, that means that the solution at that interval, a interval lo a curve ka solution e ledu. అర్థమవుతుందా? సపోజ్ ఇఫ్ ఐ లాస్ట్ మై రింగ్ in this room, it's waste of searching my ring in the other room where we have light, isn't it? సో నేను ఎక్కడ పడుచుకున్నాను అక్కడే ఎత్తుక్కోవాలి. అట్లనే ఇప్పుడు నాకు ఇంటర్వెల్ ఇక్కడ 2, 3 లో నాకు ఆన్సర్ రావాలి అంటే ఇక్కడ రావట్లేదు. ఇది ఎందుకంటే ఆ కర్వ్ దిస్ ఇంటర్వెల్ లో అక్కడ ఎక్కడ టచ్ అవ్వట్లేదు, బికాస్ ఇట్ డజంట్ హ్యావ్ ఎనీ in a point of intersection of the curve with the x-axis. So manaki solution undadu. So ivanni ultimately so interval solutions untaya leda, so whether we are able to get the solution or not, or sometimes no, how the curve is moving ante adi increase avutunda, whether it is decreasing or it is going to the peak points or the having the minimum points, all this, that is knowing about the characteristics of the curves. We are going to learn first the mean value theorems. Mean value theorems nunchi emavutundante we can tell whether the functions are increasing or decreasing, whether they are discontinuous or not continuous అని చెప్పొచ్చు. So if it is continuous అయితే మనకి at what point, up till what point the curve is going, a peak work point curve వెళ్తుంది, what is the maximum value, okay, all that we can discuss, which is the second part of the third unit. For this purpose this mean value theorems are discussed, children. Look children, see the functions will be varying amma. Functions మనకి ఏది పడితే అది ఇస్తుంటాడు, ఇంటర్వెల్ కూడా మారుస్తూ ఉంటాడు, right? Okay, so we can't we can't tell as we like, right? Okay, so first we need to understand the concept properly. We have to understand the concept properly, because we need to apply the concept to random questions and in random intervals. Okay, all questions are not alike. We don't get any fixed problems here. Okay, the student should understand the concept of continuity and differentiability, and he should be well prepared to give answers whether the RMVT, that is Role mean values theorem, is applicable kada, or Cauchy's mean value theorem is applicable kada, or what you have, that is Lagrange's mean value theorem is applicable kada. If it is applicable, where the point, the C value, at what point the curve meets the x-axis, at what points the curve meets the x-axis. So all that we need to understand. Okay, so emana doubts unte cheppandi. Attendance is taken in the Zoom itself. Zoom ante record తీసుకుంటే వచ్చేస్తుంది. So don't worry about your attendance. Attendance ఇది automatic generate అయిపోతుందమ్మా దీంట్లో. ఇంకా any doubts? Excellent work. No doubts. మీకు ఇప్పుడు ఏం నో యూ డోంట్ హ్యావ్ ఎనీ డౌట్స్ అమ్మా. ఇప్పుడు ఏం రావు, అది మనం అప్లై చేసేటప్పుడు కంపల్సరీ వస్తాయి. సో యూ టెల్ మీ వెన్ మీకు ఇప్పుడు అర్థమైనంత వరకు, వాట్ అప్ టిల్ నౌ. ఓకే, వెన్ ఎ ఫంక్షన్ ఇస్ సెట్ టు బి, it is compulsory to attend on the, yes, it is compulsory to attend the online classes, Amma, because here when you log in, no, the time, the duration that you are there here, automatically it is generated, guys. సో మీరు, నేను ఇప్పుడు ఎక్సెల్ షీట్లో అటెండెన్స్ తీస్తే మీకు వచ్చే, మీరు ఎంత ఏ టైంలో లాగిన్ అయ్యారు, ఏ టైంలో లాగౌట్ అయ్యారు, ఎంత టైం వరకు ఉన్నారని కూడా తెలుస్తుంది. సో 1 minute 2 minutes 5 minutes అట్లా ఉంటే అది అటెండెన్స్ తీసేస్తారన్న. ఓకే, కంప్లీట్ గా ఉండాలి. ఇది క్లాసెస్ మీకోసం, మా కోసం కాదురా అమ్మా. దిస్ క్లాసెస్ ఆర్ టేకెన్ ఫర్ యువర్ సేక్. మా సబ్జెక్ట్ చెప్పుకోవడం కాదు ఇక్కడ మీకు అసలు, because we won't get again and again this. There is no repetition of this subject which we are taking in online. So please be attentive. అందుకే నేను ఎన్ని ఎగ్జాంపుల్స్ తీసుకుంది కూడా, సో మెనీ ఎగ్జాంపుల్స్ హ్యావ్ టేకెన్ టు మేక్ యూ అండర్స్టాండ్, బికాస్ టిల్ నౌ యూఆర్ హ్యాంగింగ్ ఆన్ మ్యాట్రిసెస్ విచ్ ఈస్ అ వెరీ సింపుల్ టాపిక్. ఓకే, దానికి దీనికి పొంతన లేదు. ఫస్ట్ 2 topics and third topics has no interlinked. I've told it already. ఇది బాగా కాన్సెప్ట్ డెప్త్ ఉండే టాపిక్స్ ఇవన్నీ. దట్ ఈస్ ద ఫంక్షన్స్ ఆఫ్ సెవరల్ వేరియబుల్స్, మీన్ వాల్యూ థియరమ్స్. Of course, problems are very easy, guys. Problems are very easy, but before writing any statement, we have to think once or twice. ఎట్లా పడితే అట్లా రాయడానికి వీళ్ళు కొద్దిగా మనకు మీనింగ్ తెలుసుంటే అప్పుడు దాని గురించి we can write it very easily, right? Okay. ఏమైనా డౌట్స్ ఉన్నాయా? Tomorrow I am going to give the definition slowly. Definition of continuity, differentiability with examples. ఇచ్చి మెల్లిగా స్లోగా స్టార్ట్ చేస్తాం, because we have much time. ఫర్ ఫస్ట్ మీట్ ఇంకా టైం ఉంది కాబట్టి. ఇంకా ఈ లోపు ఏమైనా డౌట్స్ ఉంటే మీరు చెప్పండి అమ్మా. I asked the man to unmute it, because ఈ mathematics లో sharing ఉంటేనే I could able everything. I can't put it in the you can't write it in the chat box కదా. సో మేడం నా రిక్వెస్ట్ చేస్తాను, రైట్? ఓకే, see, so this is such a lengthy topics we have. Once again I am showing you the topics in these 3. This is on the first 2 on single functions, and this is on double function. Cauchy's theorem is on double functions, right? Okay, all the problems looks alike, but there is small deviations there. అది మనం పట్టుకుంటే mean value theorems becomes very easy. Once again, these theorems are held without proof, nana. ప్రూఫ్ లేదు, ప్రూఫ్ అవసరం లేదు. అండ్ హియర్ ఫంక్షన్స్ ఆఫ్ సెవరల్ వేరియబుల్స్ లో మనకి ఇది చాలా ఈజీగా ఉంటుంది. వీ షుడ్ నో వాట్ యూ మీన్ బై ద పార్షల్ డిఫరెన్సియేషన్. అది చాలా టైం తీసుకుంటుంది రావడానికి. పార్షల్ డెరివేటివ్స్, హౌ టు వర్క్ అవుట్ ద పార్షల్ డెరివేటివ్స్ అండ్ వాట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ ద టోటల్ differentiation and the partial differentiation. And suppose, and after getting a command in the partial